Okay, so Jim kind of took us a little bit away from Emiquon. I'm going to bring it back a little bit. I am a tech crew lead with the Illinois River Biological Station, working for the Illinois Natural History Survey. This project was actually funded and guided by the Illinois Department of Natural Resources. I'll be looking at an evaluation of carp use of a steeppass fish ladder. So this project evaluates the use of a new steeppass fish ladder designed for the management of Asian carp and native fish passage. For this presentation, I'll be taking a look at what's the issue in the Illinois River with Asian carp, be introducing the fish ladder as a new possible means of management, and taking a look at what we were able to observe, as well as looking at what we were hoping to see, which would be Asian carp species using the ladder. So I guess background on Asian carp. In the 1970s, 2 species of Asian carp were implemented as biocontrol of algae in agricultural facilities in the United States. Commonly referred to as Asian carp, they were the bighead and the silver carp. In the 1980s, both carp species actually escaped the agricultural facilities and started to spread throughout the Illinois Midwest waterways. They were seen in the Illinois River starting in the 1990s and have been slowly moving towards the Great Lakes. Asian carp have continued to be a threat to Illinois waterways and native species, and additional methods for their management, control, and removal are being explored. Management efforts currently ongoing are barriers, electrical barriers actually, and other deterrents to try to stop their spread at the leading edge of their invasion, as well as mass harvest efforts are being done to remove large parts of the population, and commercial fishing incentives are being explored to promote an increase in harvest. For this project, our goal was to introduce a new management option for managers to add to their portfolio. To take a look at some of the behaviors of Asian carp that might be utilized is they are attracted to the flow, for upstream movement and for spawning. So we wanted to see if this behavior could be exploited for their possibility of removal, and look at how that might be beneficial for this new technology of a fish ladder. So what is a fish ladder? A fish ladder is actually a passageway that allows fish to move around barriers in their home range and migration pathways. So there are many designs, including stairways that are built into dams and ones that use tubing to propel fish over an obstacle. We actually worked with Whoosh Innovations to install a steeppass design. This design actually uses a water source to run the system. In our case, we actually used the Emiquon pump station to utilize the system. So we had the pumps running and that would fill and run the system. The main passage that the fish actually go through has 3 parts: the steeppass, the flow box, and the false weir. So the first portion is actually the steeppass. Fish will enter this from the spillway, which is connected to the Illinois River, and they'll swim up a steep incline into the flow box. So the flow box is actually directly connected to the water source through a series of valves that control the outflow. So this will actually allow the water to come into the flow box and then down the steeppass, but it actually has an added kind of like grid at the back that will allow some water out the back and allow it to kind of churn to guide fish towards the false weir. From the false weir, they're actually pushed into the holding pool that we utilized. The holding pool that we used was actually the south channel of the pump station, which had been separated from the spillway prior to installation with these blocks that you can see in the picture. To be able to verify that the fish collected from the pool were able to move through the ladder, we installed a set of cameras to review the footage later. The cameras were actually internet-controlled security cameras provided by Whoosh Innovations, and we set them to run 24/7. So here we have, provided by Doug, we have some footage of the system running. So you can see on the north channel, we have it pumping and the water's turning out, and it comes out these tubes and fills up the flow box. And you can see it just churning down the steep pass. I apologize. So when considering a new management method, we had two main objectives here. We wanted to look and see if fish were actually going to be able to utilize the system and move up the ladder. We also wanted to look at what could be attracting them to the area to use the ladder. So the steeppass was installed and tested at the Emiquon water control structure. From Doug's information, we know the structure is actually being used for habitat control and water levels within the preserve. And we were able to set it up and run the system in the fall of 2020. We were able to do a 3-day trial starting on the 14th of September. We started the pumps and then turned them off on the 17th with a day of collection before and after. So the whole trial ran from the 13th of September to the 18th. So fish were collected from the holding pool after the trial. The holding pool was cleared as best as possible before the trial began. And when the fish were collected, they were weighed, measured, photographed, and identified. The native species were returned to the spillway, and then the invasive species collected were removed for proper disposal. The camera footage was collected each day to be able to review after the trial was completed. So we also had water quality parameters selected at 6 different sites. We collected water samples as well to look at zooplankton, turbidity, and chlorophyll. So after the trials, we now wanted to take a look at what we were able to see. So the first objective, will fish be able to use the ladder? We collected 76 fish from the holding pool after the 3-day trial. We identified 7 different species with 5 native and 2 invasive, with gizzard shad being the most abundant. Now, to verify how well they were able to go through the ladder, we compared the video footage that we collected, and due to low camera resolution and some internet issues, we were only able to see 30 fish moving through the ladder out of the 76 that were collected. The most surprising of the fish that were seen on camera moving through were the bluegill and the warmouth. You see it just comes out a little bit there. So we also wanted to take a look at the sizes of the fish that were moving through the ladder. The graph on the right is all of the fish that were collected from the holding pool at the end of the trial and their sizes and count. On the left, we have a histogram from the LTRM Lagrange Reach collection of 2020, showing the silver carp that was collected in that year and their size range. So majority of the fish that were collected from our holding pool were between 150 and 400 millimeters in length. Comparing that to the size, that same size range on the histogram, there's not a whole lot of fish representing that size range in silver carp. Most of the silver carp collected during this time period was closer to 600 millimeters in size, much, much larger than most of the ones that we were collecting. After taking a look and seeing how well the fish were able to move through, we wanted to look at what might be attracting them to the ladder and how they might be interested in using it. So this actually shows the water quality parameters that were collected in the spillway during the time. So across the bottom, we have the date and time in 4-hour intervals. We've got turbidity and chlorophyll. These two were actually collected from a sonde that we put in the spillway during the trials and was set to take 24-hour sampling. So the turbidity and the chlorophyll we're able to see before this dotted line comes in, which represents when we turned the pumps on. There was a little bit of evening out, and then once the pumps turned on, it had a sharp incline up. The second dotted line represents when the pumps were turned off, and you can see both had a decrease just a few hours after the pumps were turned off. So above the chlorophyll, we have the zooplankton samples that were collected. This was actually a subsample that I was able to process before this presentation. And we can look at before, during, and after the pump trials. We can see that there was a low abundance within the spillway before the trial started, and then it increased very, very sharply and continued to increase over the time period that the trials were ran, and then started a decline after they were turned off. So above the zooplankton is the river stage data. This was actually collected from the Havana gauge, and it was showing the river stage was actually at 8 feet when we started the trial, and over the 3-day period declined to closer to 7 feet by the end of the trial. At the top, we have the fish that were actually seen on the camera in the time periods that they were actually moving through to look at a comparison for time range if possible. So what we weren't able to see, we didn't get any silver or bighead carp moving through the ladder. So water levels likely played a big role in inhibiting Asian carp from being able to use the ladder. The steeppass was actually set on the bottom of the spillway bed, and the steeppass opening was only about 3 feet tall. And you can see from these picture series that the water within the spillway only filled up enough to almost get to the top of that steeppass opening. After looking at this and looking at the size range, we had some discussions with the Whoosh biologist on staff and determined that the fish were not able to utilize a plunge pool to be able to get into the ladder. A plunge pool is actually a room for the fish to be able to dive down to get momentum to leap up. So this is potentially why we weren't able to get any bighead or silver carp to be able to utilize it. So in order to make the ladder more accessible, we'll actually be elevating the ladder up off of the bed in order to allow that use of that plunge pool to come through. So some other issues that we ran into included the cameras. The holding pool wasn't able to be drained, and the time of year. With the cameras, we actually had trouble with internet connection since they were internet ran and they were actually ran through an app on the phone. We had some connection issues with getting those to run. They also had very low frames per second, which also made it difficult to be able to catch images. The picture I have here, I saw a fish, but I wasn't actually able to catch a frame of it. So there's frames missing within there. The holding pool was set up prior to installation, and we wanted to try to drain it before starting the trial, but we're not able to properly pump out water. So to combat that, we were able to use a seine to move fish prior to as best as possible, and after the trial was done. The time of year, it was the fall of 2020. So that's a time period where fish are preparing to overwinter, and they weren't as active as we were hoping. So we plan to conduct a second trial in the spring of 2021 with lessons learned from 2020. So in addition to elevating the ladder up off the bed, We'll also be installing an AI scanner, which will allow us to take multiple rapid photographs of the fish moving through, as well as be able to identify the fish. I included a link here. This is actually to the Whoosh Innovations YouTube channel, where you can see some other footage of the scanner working. We'll also be adjusting the holding pool setup to be able to fully empty it before and after to make sure we don't have anything missed during our removal. We'll also be continuing to complete the zooplankton sampling processing from last year and process all of the sampling for this spring's collection as well. So after we've completed these trials, we'll have a proof of concept for the use of the technology by both native fish and invasive Asian carp. This system will then be considered for installation for management as well, and will possibly be moved to different areas where Asian carp are being managed. So that's all I have for today. Do we have any questions?